We are going to go back to looking at using characteristics of the derivative to draw a graph. So we've worked on this in pieces, and now we're going to put everything together. In the pieces, we looked at how to find the intervals of increase or decrease. We looked at the max and the min values. Number one, we have y equals x to the third plus 6x squared plus 9x. So we need to try to graph this. Now we're not going to just put it into our calculator, do a table of values and graph it. Instead, we're going to use our calculus that we've been working on to work through all the different characteristics, and then we'll use the characteristics to draw the graph. So first things first, if you notice in part A, it says to find the intervals of increase or decrease. So that means that we need our first derivative test. So if we need our first derivative test, first we need our first derivative. So let's start there. So our first derivative will look like y prime equals the derivative of x to the third is 3x to the second. The derivative of 6x squared is 12x. And the derivative of 9x is 9. Now, right away, when I look at this, I see some things in common. I see a common 3 all the way through. I know in order to do my first derivative test, I have to take the derivative and set it equal to 0. So I'm going to set it equal to 0, and I'm going to factor out a 3. The reason I'm going to factor out a 3 is because if I factor out a 3, it'll make factoring what is left a little bit easier. If you did not notice the 3 to factor out, that's okay, because when you go to do your factoring, it'll be okay. You'll just have a multiple of 3, and then you'll cancel it out when you solve down anyway. So don't stress about it if you didn't see it. I think it's a little bit easier to guess and check the factoring if I can pull out the GCF first. So that's why I went ahead. Now here I'll divide both sides by 3, which will leave me with x squared plus 4x plus 3 equaling 0. Now I can factor this, and that will look like x plus 1 and x plus 3. So to factor it, remember we need two numbers that multiply to 3 and add to 4. So looks like 1 times 3 is 3, and 1 plus 3 is 4. So set each of these factors equal to 0. So 0 equals x plus 1, and 0 equals x plus 3. Now I can solve it down, and I get -1, and I get -3. So that means I have two critical numbers. So remember, the zeros from our first derivative test were our critical numbers. So these are our critical numbers. So -1 and -3, or -3 and -1, however you want to put them in order, are our critical numbers. So next, we draw our first derivative test table, and we use our critical numbers to split apart our table. So let's start with our intervals. And we need our first derivative, and we need to know if that is increasing or decreasing. All right, so I'm going to split my intervals at my critical numbers. So -3 and -1. So this will be -3 right here, and this will be -1. So if I look at my intervals, that means that we go from -infinity to -3, and then -3 to 1, excuse me, -1, there we go, and then -1 to infinity. All right, so there's our intervals. So now we need to check our first derivative sign. Now we're checking the sign in the first derivative. So don't put it back into the original, put it back into the first derivative. See right here, we're checking the sign of our first derivative. So we need to put everything back into the first derivative. So I need to check something that is between -infinity and -3. So how about -4? Let's put -4 back into our first derivative. It doesn't matter what the value is, more so what we're looking for is the sign. So let's see if we can figure this out. So we did -4. So let's put it back into our first derivative. So -4 squared is +16, And then right here, we'll have 4 times -4 is -16, so that'll cancel. And then we'll have our 3 left over. So if we multiply the positive here by the 3 that we would have here, it looks like we're going to get a positive. And if you're saying, wait, what just happened? Use your first derivative right here and put in the number we picked. So in this case, we picked -4. And then go ahead and solve this down. We don't care what the value is. What we care more so about is the sign. All we need to know is it positive or is it negative? 3, 7, 12, 15, we don't care about that. We care about the sign. So as we go down through, -4 squared is positive 16. Positive 16 times 3 is 48. And then we have our 12 times -4, and 12 times -4 is -48. So those two are going to cancel each other. But then we still have +9, which leaves a positive value for the overall first derivative. So that means in this interval it's positive. So then we do the same thing again. Let's check our next interval. So our next interval is from -3 to -1. So there's not a whole lot of space in there. Let's try -2. So same idea. If we go back to our derivative right here, and we put in -2. So we'll have 3 times -2 squared plus 12 times -2 plus 9. So -2 squared is +4. +4 times 3 is 12. 12 times -2 is -24 plus 9. So that's going to give us a negative. It doesn't matter, again, the exact value, but that's going to give us a negative. So in this interval, we have negative. And then we do the same thing again, and we test the last interval. Now, -1 to infinity, 0 is in that interval. And as 0 is in one of the intervals, I pick 0. You don't have to if you don't want to. I like a good 0. So if I put 0 in, it looks like we're going to get +9, so it's positive again. So again, pick any number that is within your interval. It doesn't matter which one, as long as it is inside your interval. Do not pick an endpoint of the interval. Like in this case, do not pick -3 or -1, because that will give you 0. We need to see if it's positive or negative, not 0. So we need to pick something that is not 0 and check inside our interval. All right, so next we have our increasing and our decreasing. Well, what does this mean? Look at the signs that you got from your first derivative. The first derivative test told us that this first interval is positive, so that means that it is increasing, so going up. The second interval right here is negative, so decreasing. Let me try again. That looks like it's straight. Needs to be going down. There we go. And then the third interval here is increasing. So if you notice, it goes up and then it goes back down. So this is going to be our max, and this is going to be our min. So just looking at it, we were able to figure out our max and our min. So now we should figure out the coordinate for those max and that min. Well, in order to figure out our coordinate, we need to go back to the original. Anytime we're looking for a coordinate, we should use our original. So let's look and see if we can figure out f of -3. So that will look like -3 to the third plus 6 times -3 squared plus 9 times -3. So we need to figure this all out so that we can see what our coordinate is. So if we have -3 to the third, that means -3 times -3 times -3. And if we multiply that all through, we'll get -27. -3 times -3 is +9. And 9 times -3 is -27. So if we try to solve this down, solving this down, we'll get 0. So now we have our max. Our max is -3, 0. Okay, let's try the same thing for our min. So now we need to figure out f of -1. So that means we have -1 to the third. And then we have plus 6 times -1 squared plus 9 times -1. So negative 1 to the third is negative 1. Negative 1 squared is 1 times 6 is 6. And then 9 times negative 1 is minus 9. So that looks like negative 10 plus 6, so that'll be negative 4. So our coordinate for this one looks like negative 1, negative 4. So now we have some points that we can add to our graph. When x is negative 3, y is 0, so that is right here. When x is negative 1, y is negative 4. So that is right here. Okay, so now let's go back to our list. What did we need to figure out? Find the intervals of increase or decrease. We did that right here in our first derivative test. Find the local max and local min. We did that in green, so we got that part. Find the interval of concavity and the inflection points. Okay, we didn't do that part yet. In order to figure out concavity, we need a second derivative. So let's go back to our first derivative and let's get our second derivative. So our second derivative will look like 3 times 2 is 6, so 6x, and then plus 12. Second derivative test says take the second derivative, set it equal to 0, and solve for x. So if we solve it down, it looks like we get x is equal to negative 2, and that is our inflection point. And we need to make our table. We need to test our intervals. We need to check our second derivative, and we need to figure out if it's concave up or concave down. I only have one inflection point, so that means I just need to split my interval in one spot, and that will be at negative 2. So my interval will go from negative infinity to negative 2, and then the second one will be from negative 2 through infinity. And now we need to check our sign of our second derivative. So pick a number between negative infinity and negative 2 and put it back into your second derivative. So let's pick negative 3. So 6 times negative 3 plus 12. Well, that'll look like negative 18 plus 12. It doesn't matter what the number is. What we care about is the sign, and the sign will be negative. So if the sign is negative, that means it's concave down. So let's pick another number between negative 2 and infinity. So 0 is in that interval, and I told you if 0 is in the interval, I like to pick 0. So I'm going to pick 0, which will give me 0 plus 12, so that's positive, which means it's concave up. So now I need to figure out the other half of this coordinate. So we have negative 2. Let's see if we can figure out the other half of the coordinate, the y value, so we can have a new point to plot. So we need f of negative 2, and that will look like negative 2 to the third plus 6 times negative 2 squared plus 9 times negative 2. Squeeze it in there. I'll scoot it all over. Try again. Negative 2 to the third plus 6 times negative 2 squared plus 9 times negative 2. That wasn't any better. There we go. All right, so if we solve this down, it looks like we're going to get negative 2 for our y coordinate. There we go. Now we have a point. So negative 2, negative 2. So x is negative 2, y is negative 2. That's right there. And that's going to be our inflection point. Now let's look at this. Are there any other nice points? We don't really have a whole lot of points here, but are there any other nice points? Well, if I put 0 in, so we're just going to say nice point. If I put 0 in for x, I'm going to get 0 for y. So that one's not so bad. So I'm going to label that a nice point, and I'll put it right here. Now let's check the end behavior. Let me get a new color. How about this one? Let's check the end behavior. So the end behavior means that we need the limit as x is going to approach infinity, and we need the limit as x is going to approach negative infinity. So let's look back here at our original equation. If we pick values that are approaching infinity for x, so bigger and bigger and bigger and bigger, what's going to happen to y? Well, as x keeps getting bigger, we're going to go to infinity. Now let's check again for negative infinity. If we get numbers that are approaching negative infinity for x, what's going to happen to y? It's going to go to negative infinity. So that means for our end behavior, the right end is going up and the left end is going down. So now we can draw in our graph. So the left end is going down. It is concave down up to -2. So concave down up to -2, left end is going down. At -2, it switches to concave up, and it is going to be increasing from -3. So concave up here, increasing. There we go. It looks kind of like a sharp point. Let me see if I can round it out just a little bit. Try again. There we go. And we have our right end increasing as we go. So that will correspond to our end behavior from over here. It looks like we've got it. Let's check. Increasing to -3. We should have a max at -3. So increasing to -3, we got that. We have a max at -3. Decreasing from -3 to -1, we should have a min at -1. We've got that. Increasing after -1, we've got that. And changing concavity at -2, -2. It looks like we have our graph for this first one.